your millions of viewers.
Say it again?
For your millions of viewers.
Absolutely. International viewers. Sorry, just going off in my own head on just the people who watch some of this stuff and comment. Anyway. So now if I'm finding the torque about this point, so becomes very similar to the lab, and we pick this as our pivot point, then I basically have the torque from the tension plus the torque from the weight plus the torque from the normal force, technically plus the torque from normal force 2.
Which is 0.
Is equal to 0. That's 0. And torque is R cross F.
Is that a negative sign in front of the first torque?
That?
Yes.
No, that's a straight mark.
Okay. They should all be positive.
Well, I'm making them all positive here because I still have the vector symbol over them.
Mm-hmm.
The next step is when the plus or minus sign is going to come into it.
Okay.
And you can do it two ways. You can go set up your I hat, J hat, K hat, like we've been doing, use right hand rule. Or just use the right hand rule. Imagine I've got a stick right here pivoting about that point. And did I really take all the meter sticks away? So this force right here would cause this to rotate from your point of view, clockwise or counterclockwise.
Clockwise.
Okay, clockwise.
Yeah.
The weight, is that causing it to rotate clockwise or counterclockwise?
Clockwise.
And the normal force, clockwise or counterclockwise?
Counterclockwise.
So the sum of the clockwise torques should also equal the sum of the counterclockwise. That basically takes the sign into it already. So, I didn't put a subscript here. This is, that's tension. Ooh. These two are trying to rotate in one direction. That's trying to rotate it the other direction.
Mm-hmm.
Either that's negative or they're negative. Take it over to the other side, and what I'm left with is and now R cross F. When doing R cross F, if I have the weight acting down right there, technically R is a vector from the axis of rotation to where the force is applied. So that would be R. That is F. The angle between them, I know the magnitude of the torque is equal to the magnitude of R times the magnitude of F times the sine of the angle between them when they're tail to tail. So if I have R going this direction, F going that direction, what is that angle? Well, we have enough information. We can find that angle if need be.
Unless it's given, it could be given. To do that, you would just do R times F or whatever it's going to be set equal to, would it be sine or would it be cosine when you're trying to figure it out?
For cross products, if they're tail to tail, it's sine. Now, if you're looking at it from this point of view, then you have to think through it and go, all right, is it cosine of this angle or sine of this angle? But if I know what this angle is down here, that's the same as this angle right here. And then I would just add 90 degrees to it. Do you need me to actually plug in numbers?
No.
Okay.
He said 90 degrees. So that the F is that straight down.
Yes, wait. It defines the direction of down. Carolyn?
I watched a video about how to do this one, and it, instead of doing the sign of the angle in between them, and it like made R like perpendicular.
Okay.
So you didn't have to do anything, and that seemed a lot. Like I mean, you still have to
You
do
didn't have
stuff.
to do anything.
You don't have to like do the trig function.
Alright,
Well,
way I was thinking you were referring to it, you still have to use the trig function, just in a different spot. But let me do another way of doing it, and then you tell me a third way. Alright, so technically, R cross F, this is the technique. Now, as it turns out, it also works to there's my force right there, there's from the weight. R is going in that direction. I could just imagine weight's going down, and I just look for the shortest distance here. So I could find R, so that's the magnitude of R. If I know that angle, this would be R cosine theta.
Yep.
And in the lab, that's what I asked you to do, is to find that distance. Was that, but that's not the way you were talking about.
It was exactly what you said, except without the cosine. Like they made R just like the horizontal distance, and I came out with the same answers as your answer.
Alright, so you made R the horizontal distance.
Yeah. And
But-
that was just R.
Yeah, but how do they find the value of R?
Like.
Similar triangles? Did you wanna come up?
I don't know.
It would give you an alibi.
Like based on the lengths we already know.
Okay. So, to find that distance without, if you want to pretend you're not using trig, that's fine. I know that this distance here is half, well, I know, let's see, what do I know? Stick it over here. I know this is 1.3 and this is 0.55. Use Pythagorean theorem, you can find this distance right here. Whatever that is. So, officially no trig. Then, I can figure out where weight is, because I know it's the halfway point. So this will be half of whatever the hypotenuse is there. This is the halfway point, so this distance here would be 0.65. And actually, it probably would be half of that, so 0.275. There you go.
Yeah.
That work better for you?
Yeah. So in that case, for weight,
Yeah.
R is 0.275.
I think. I would contend R is still that length officially, but when you bring in the trig, so when you do R sine of that angle or R cosine of just that angle, you should get 0.275.
Okay.
So, using this, do you not already have that? If you decided that it's halfway down the slope to get for weight, then if you've used your Pythagorean theorem to get the total length, do you not just have that, and then you have your others?
Then you have that, yes.
Yeah, okay.
And then you can do Pythagorean theorem again to get this. Cool. Now recognize that what I just did is based upon similar triangles. That this triangle here has the exact same angles as this triangle here, so they're proportional. So that to that is equal to this to this.
Right.
Well, if I look at it a slightly different way, so what we call this big A, big B, big C, little a, little b, little c. Similar triangles. Those angles would be the same. Doing it with proportions, I know that A is to C, is the same proportion as little a is to little c. That's the essence of similar triangles. Well, a is to c is just the sine of theta. That's theta. That's all the trig is looking at similar triangles and comparing the ratios. Some consider it faster, some do not.
So, this part right here where it's R and F, we cut the angle in, yeah. So, is that just that you're adding vectors?
No, we're not adding vectors. Adding vectors, I would put them head to tail. When you're finding the angle between vectors, you put the vectors tail to tail.
Okay.
All we're doing is just finding the angle. And so if this angle here is theta, you would do RF sine of theta. Sine of 90 degrees plus theta.
Okay.
And that is just. It's like a theta.
So, why?
You're in trade now, right?
Yeah.
Okay.
And I kind of understand this part, but. Plus sine beta cosine alpha. Okay, that
Right.
was just,
So if alpha is 90 degrees, then sine of alpha would be 1.
right,
Cosine of alpha would be 0.
right.
So if the second term drops out, what we're left with here is just cosine of beta.
One last question, that's not related to this, in one of the first problems, it had the foot-pound, what's that called? Like ratio, is that gonna be on it, if we have a problem like that?
No.
So we're supposed to know the foot-pound ratio? Cause it
You
was.
mean the conversion of foot pounds
Yeah,
to
yeah.
Newton meters? Oh, I would give that to you if you needed it.
I think foot-pound is a funny way of saying it.
Newton meter sounds more normal to you?
Yes, it does.
The Metric Conversion Act of 1972 is finally kicking in. Or 73, one of those.
I have one more question. When you did the, like tail to tail over here,
Mm-hmm.
you were making the axis of rotation the bottom, right?
No,
I think you like switched.
you're correct, I did switch.
Okay, so if you were to make it the top, then R would be going that way.
Yep.
Wait, going that way, so it would make like that angle tail to tail.
That is correct.
And it would be the same thing
Then it would,
if you do the sine?
so putting the rotation, the axis of rotation back at the top. So R is this way. So R, F, that angle right there. Actually, would be theta prime. This angle down here would be theta. So this would be the complement. So the sine of theta prime would be the same as the cosine of theta.
Okay.
And that's different because you're doing it from the top.
Yeah, which is where I started, and then I somehow changed. See, I can change as a person.
In physics.
Okay, it's a start.
It's a start. But why, like, where is weight involved in this new equation, or in this new triangle?
In the.
That's what this,
Oh, okay. I thought that was friction. I mean, tension. Never mind. Going back to this trick up here, what are you setting that equal to?
That's equal to this. You asked what I heard you ask is,
Yeah.
why is the sine of 90 degrees plus theta equal to cosine theta?
I get that, but,
And so this is the formula for this sine of the sum of angles.
right, and so when you're solving for theta, are you arc signing, or how are you gonna end up?
Oh, when I solve for theta
Yeah,
in this particular problem? Well, I know I'd do an arctan probably. But I know that's 1.3 and this is 0.55. That's my angle theta right there.
Mhm.
So I know the opposite, I know the
Okay,
adjacent,
yeah.
so I'd use arctan.
Just move it along.
Other questions? All right, let's do this thing. I'm inclined to say that if not everyone's done in a half hour, then you have a choice of stepping out in the hallway or basically I'm gonna start half hour.
The quiz is that easy.
Or you are that prepared. Now, I did print these up yesterday, so I would not have to scramble around, run around doing that this morning. But I forgot that, a number of you don't have calculators. So I will go find a slide rule for you.
You can never be too prepared, right?